Hello everyone. In this video, I would like to describe my project, which I like to call it as Interactive Embedded Web Terminal. I built this project as part of a project for the HP Enterprises company. At the bottom of the screen, we have a form to enter SSH credentials. The objective is to achieve a connection to a remote machine running Linux OS in which a person, say a system administrator, will execute commands. In this demo, I will be entering the SSH credentials of my Linux virtual machine. First, let me enter the host name, which is the IP address of my Linux virtual machine, which is 192.168.0.204. The port is left as it is. The port is 22 because we are going to achieve SSH connection, and 22 is the default port for SSH connection. Let me enter the username for my Linux VM, which is Kali, and the password. So we can also use the SSH PEM, that is the credentials file, to achieve connection instead of the password. Now, with all the credentials entered, let me click on connect, or we can click on enter. We can press on enter. We are now connected to the Linux virtual machine. A terminal is usually a desktop application. But in this case, the terminal interface is produced in the browser, and it is present as a component of the web page that we can currently see. This is a standard feature that is present in public clouds such as GCP, AWS, and Azure. Let us now explore this terminal interface. Since this is a Linux machine, let us start with some simple commands such as hostname. So it has displayed the host name, which is Kali in this case. Now let us display the operating system information by clicking on new name. So it is showing Linux, which is as expected. Now let us issue some more complicated commands such as ping localhost. As you can see, the ICMP packets are being sent continuously. Now, if we press Ctrl C, you can see that the flow of ICMP packets have stopped. This means that the terminal interface is fully fledged. It responds to keyboard shortcuts, and it is also responding to the user input being given to the terminal interface. The only difference being that instead of being a desktop application, we have produced the terminal interface in the browser. We can also open files. So for example, if I have to create some file, let me call it as dummy. So I can always create that using vi dummy file. Here we have entered the vi editor. So let me click on I, and now let me enter some text. I have entered some text, and now let me save the file. I have successfully created a file known as dummy file. Now let me verify the contents of this file using the cat command. It has displayed the text which I had put inside the newly created file. Now let us explore an additional feature of this application. We can see there is an input box present at the top left corner of the web page. Here we can enter commands that are to be executed in the terminal. So now let me click the same commands which I had entered. For example, hostname. Let me type this command in the input box. I have typed this command, and now let me click on execute command. The command which I had entered in the input box has now been executed in the terminal. And we also got the output, which is Kali, which is the host name of our Linux machine. In addition, we obtained a color, an alphanumeric value, and the time. What are all these values which we can see? The green color here shows the command execution status. The status can either be one that is, can either be 0 that is successful, or any other value other than 0 which is unsuccessful. In this case, we have obtained a command execution status of 0, which means that our execution was successful, and hence the color has been shown as green. In addition, we can see that the time taken to execute the command has been displayed, in addition to an alphanumeric value, which I call as the command ID. The command ID is a unique value used to identify the command. The visualization of the command execution status and the time is a feature that is found on Jupyter Notebook. The Jupyter Notebook uses this feature to visualize the execution of a cell in the notebook. The Jupyter Notebook utilizes a unique value for every cell and every command output in its inner workings. In this demo, we have shown this unique ID in order to understand the workings of this web application. The feature in which a command present in an input box is transferred to the terminal on a button click is present on a software known as Katacoda, which was recently purchased by O'Reilly Company. Since we have a terminal interface in the browser as a component of a web page with which we can interact using external components, I call this project as the Interactive Embedded Web Terminal. Now, let us further explore this web application. Suppose I enter a command which does not exist, such as hostname2. We can see that the status is being shown as red. This is because the command is not found and the status is 127. And since this is not 0, it has been shown as red, together with the execution time and the unique ID. Now, let us execute a continuously running command, such as a script. In my case, the script here is as follows. The script name is script.sh, whose contents will now be displayed using the cat command. Now let me give this command. Okay, so the file has not been found. So now let us create this file from scratch. Vi script.sh. Let us create a variable A whose value is 1. Now we must keep on looping till, say, with the value of A is 30. So now let me give while $A less than 30, we must do it. So let me just use the scripting. So now let me use this script here. So the reason why I went to this website and copied this text is because I wanted to show the fact that we can paste content into the file. So now let me put A is equal to 1, and now let me paste the content. As you can see, I use the standard Linux paste key combination, that is Ctrl-Shift-V. So using this, I was able to paste content into the terminal inside the VI editor. Now let me paste some more content into the terminal. A is equal to 1, while A is less than 30. So it will loop until 30. And now what we shall do is that we will increment the value of A. So we shall do this. So I can paste it like this. And we will sleep for 1 second. Sleep 1. So we shall do this until the value of A is less than 30. So what happens here is that we increment A and we sleep for 1 second. So the effective thing is that it will keep on looping until for 30 seconds. So let us put an E lesser than or equal to. So now the shell script will make the terminal to execute something which shows the value. So let me put the echo $A. So now what the shell script does is that it displays the value of A, sleeps for 1 second, and again displays the value of A. It keeps on doing this until the value of A reaches 30. So we have the following code now that is executed. Now, let me issue this script. Let me execute the script from the external component. Before that, we must make sure that we have enabled the execute permission in the script. For that, let me give chmod plus x script.sh. So now I have enabled the execute permission on the script. So we can execute almost any type of command which does not hang the terminal. For example, if I issue vi, we can see that the status has not been displayed. This is because vi executes continuously and it can be stopped only after the user manually exits the application. So let me click on Q. You can see that now the status for vi command has been shown, 14 seconds, and the ID. So now let us execute the script.sh. So this is how we execute scripts in Linux. Let me click on execute. So it is saying that the script is invalid. Let us go inside the script once again. We forgot to put done. So now let us put that. So the reason why I am interactively using the terminal is to show how a Linux administrator can use this terminal as though he was directly executing commands on the Linux machine. Now he can connect to that machine remotely and perform the commands right from his browser. Now let me save the file. Once again, let us try executing the script. As you can see, it is showing the numbers with 1 second gap in between. So this is how we can execute the scripts in our interactive embedded web terminal. Now suppose I press Ctrl C. Before the script could complete, I have stopped the execution of our terminal. This has caused an invalid status of our external component. This is because we have stopped a command which was issued from the external components, which is our input box. In such a case, we expect the application to have hanged, but we can restore the correct status of the web application by clicking on clear pending command. What happens is that before the execution of such commands is complete, we have stopped the command. Hence, the system expects the status for that command, but the command has already been exited. Such commands are known as pending commands, and to restore the system to its previous state, that is the valid state, we make use of this button. This button is to be used only when the button input is disabled due to some error. So what do you mean by button input is disabled? Now if I click on execute command, it says that we have a command running in the terminal and we must wait for its completion. We can open a new tab for entering the commands. Let us test this. This is the tab, and we can see the such credentials are there. Just the password is there to enter. Let me put the password. And we have two sessions. We have a session here and we also have a session here. And we can concurrently execute the commands in these sessions. But now, suppose we have such a session and we don't want to open a new tab. We want to make this thing proper. So what do we do? So in this case, we have something known as clear pending command, which removes the current session and asks us to establish a new session. So when we put in the password, so we have a new session in the same tab. So this allows us to escape an invalid state which has been caused due to incorrect user activities. Hence, we must remember that when we are executing commands which have been issued by the external application, that is by the external component, we must wait for its execution to complete. Now, let me do a little modification to our code. So vi script.sh. Now, what I shall do is that at the end of this loop, I will create a new file which is known as, say, random file. So at the end of this execution, we should have something known as random file. Now let me save the script and let us verify if we have something known as random file beforehand. So for that, let me use ls. We can see that there is no file known as random file in our current directory. Now let us execute the script once again. The output is being displayed, that is, every 1 second we have the value of a being shown. Now let us do something interesting. Let me reload the web page. Okay, our terminal has now, the interface has now been lost, and we expect that the command which we issued will also be stopped. So now let us see what happens what can we see here? We can see that the color has turned green and also the time is being displayed. This is because we have an additional feature in this application. So before we go into that, let us verify whether our random file is there or not. Now, let us check whether we have a file known as random file. Yes, the random file has been created successfully. This means that the commands which we issue in the previous session and the terminal is removed during the execution, such commands will be left to execute completely. So this feature is particularly useful if there is some kind of outage and we want that command to be preserved. So this feature allows the pending commands to get executed. So as we can see that the script has created the random file even though we had reloaded the web page and removed the terminal session. This feature can be found in Azure, where if we reload the page, it does not stop the execution of a command which is already issued. We can now normally execute commands in our using the external component. As you can see, it displayed the output for hostname, hostname2. And we can also execute some continuous streaming commands like ping. So let me give ping localhost. So instead of continuously printing the output, let us stop the execution after sending 10 packets. It is sending the ICMP packets. As we can see that the ping command executed successfully. It took 9.373 seconds to transmit 10 packets, and the status is also being shown. Now, in any enterprise application, we expect some kind of logging so that system administrators can keep track of what is happening. In this case, we have two types of logging. One is the web console logging, which shows the logging which is produced by the terminal interface. It starts right from the production of the terminal interface, which shows the encoding, the WebSocket IDs, and other things such as the size. And it also shows what command was executed, and it shows the ID, and it shows the time. All these things have been logged the console so that the person who issues the command can verify whether the web application is running properly or not. Similarly, behind the scenes, the server which produces the interface also produces its own logging. So this, what we can see here is the client-side logging or the web console logging, and the second type of logging is the server-side logging. Here we can see that all the logging has been produced. So right from the first, it shows all the files which are used to produce the interface. It shows the authentication, that is, it does not display the password. It shows that it says that we have received the password and now you are good to go for the connection. So at no stage we are publicly displaying the password, so it is secure. And next we are showing that the command which we have received, the command ID, and the status, the time, and the timestamp. So all these details which are being shown will be logged in a database. The reason why we log this in a database is that we can enable the feature. Which feature? So what happens is that I had previously talked about the command ID. Why this command ID is used? What happens is that when we reload the web page while a command is executing in the terminal, the web application makes use of the command ID to search which command was executing. We check whether that command has executed or not. Until we get an execution status, we wait for that command. And when we get that status of the command, we display it here. That is the reason why we use this command ID, and we also log the information in the database. The web application queries the database for checking the execution status of the command. And once the web application finds that there is such an entry in the database, it displays that information in the web page. Here we see the server-side logging, which shows everything from the command information to the connection information and also the disconnection information. All kinds of logging has been shown here. In addition, we also have something known as a log file, which logs the terminal session. Let us check the contents of this file. We can see that the output is kind of gibberish here. The reason is that this is actually the terminal session, and if we display this text in a terminal session, then the output will be displayed as expected. So we can see that we have the terminal interface, we have the command output, and we also have the commands which are being shown. For example, we have so what happens is that these are all old commands, setting the proxy and all. So for the new one, we can see that have issued the ping localhost. So it is being shown here. And we have the output. So this is an option which allows us to log terminal sessions, which is useful for both the server administrator and also the client who is using the terminal. So this is more useful for the administrator because he can check this to find if there are any errors in the application or not, and he can rectify them. So this application is an amalgamation of all features that we can find in enterprise level applications. So if we have to summarize, we saw that this terminal interface being produced in the browser is a standard feature of public clouds. The input for the command and the visualization of the command execution status and time, along with the command ID, is a feature that is found in Jupyter Notebook. The transfer of commands from the external components to the terminal is a feature that is found in Katacoda. The prevention of pending commands from being killed during their execution is a feature that we can find in, I think, most of the clouds, but the cloud which I have seen this working is the Azure cloud. In their cloud, we can see that if we issue a command and we reload the web page while it's running, that command will be allowed to complete fully. So this is a feature that was found in Azure. And this is a feature where we can produce a new session in case the existing session is invalid because of improper interaction. And finally, we have the login being produced both on the client side as well as the server side. This application has been produced using Python on the server side, and it uses the HTML, CSS, and JavaScript to produce the web page as being shown. In addition, to enable the feature of pending commands to complete, we make use of the MySQL database. This was all about the execution of our application. Thank you.